Yes, sir, we can.
Okay, we will studying about the heat and temperature, right? So next method is conduction, how heat is transferred. So in conduction, best conductor of heat are metal, since the electron which carry electric current can also carry energy from hot part to the cold parts, right? So this is a metal, suppose this is a copper wire. When heat transfer from A point to B point through the electron, right? So electron of this point heated, then it transfers the energy from one point to another point. It transfers the electrons to the another points, right? In the similar manners, conduction happens in the solid. Next point is gases. Gases are by comparison poor conductor, since the molecules which make them are relatively far apart and do not collide very often, right? Gas particle is here, so they transfer the energy from one point to another, but gas particles are far away from each other, right? So they are poor conductor. So in gas or liquid, convection which involve heat being carried by circulation of the fluid tends to carry more heat than conduction. So in gases or liquid, they carry more amount of energy, right, in comparison to solid. So heat can also be transferred by radiation, which do not require any material through them. So heat can be also transferred through the vacuum, though they do not require any medium. Medium means like solid, liquid, gas. So any material it doesn't require. So heat can be transferred in solid, liquid, gas, all the form. Solid, liquid, gas. And in vacuum also it can travel. So write this point about the conduction. Now next topic is convection. So convection is the process in which fluid which of change in density. Because of the change in density, liquid or gas rises or falls. Okay, in convection, convection mostly happens in the liquid form, right? Because of the change in density, liquid or rises or falls. For example, if a liquid is heated, the liquid nears the heat source warm up first and expand, right? The next point is it becomes less dense, therefore tends to rise. Okay, when we are heating the liquid, that time its density decreases, right? That's why it is rising. The cold fluid comes in to take this place. The rise of the hot fluid and fall of the cold fluid transport heat from one place to another, right? In this way, hot fluid rise and cold fluid falls down, right? Heat also travel by the conduction and radiation, but they do not involve the movement of the material itself, right? In convection, only in liquid form, only matter rise or fall. Suppose we are heating here liquid, so this particle will rise up to this point, and when it is cold now, it will come down. So this is the process for convection. Next point is convection is important in heating and is insulating homes. Next point is a storage heaters and central heating radiator warms a room by producing convection current, which distribute the heat air around it. So this is the point for convection. Please remember. Now next point is convection. Look at the next point, convection. Convection is the transfer of heat through a body by the hot particles themselves moving from one place to another place. ठीक है? So in convection, hot particles transfer from one place to another place. ठीक है? क्योंकि mostly convection happens in the liquid. So transfer of heat by convection takes place in the liquid or gas only, not in the solid. So it only prefers the solid or gas particles. It doesn't occur in solid because the particles in solid are not free to move about. Okay? They are tightly bonded now, so they only transfer the electron from one particle to another particle. Now look at the example. Potassium permanganate is here. To observe a convectional current, place a few purple crystal of potassium permanganate with a beaker of water and heat. So we are heating this potassium permanganate. So you can see the particles are rising, and after cooling down, it is coming down, right? So first it rises, and when its temperature goes down, then particles comes down. So this is the process for the convection. Now next point is convection also occur in the atmosphere, right? So rising current of warm air can flow birds to soar for very long time without flapping their wings at all, right? So this is the example of convection. So here diagram is made. I will explain it. So let me explain. Now look at the next point, land and sea breezes. So look at the first sea breezes. During the day, air blow from sea to land, right? During the daytime, from air comes from the sea and it is moving towards the land, right? So this is called sea breeze. And next one is land breeze. During the night time, air blow from land to the air, right? So this is the process happening at the daytime or night time. Next point is land gets heated faster than water. So it also cools down faster than water, right? So land is the solid particle, na? That's why it get heated fast and cools down also fast. But in the on the other hand, sea gets heated less quickly than land. It also cools down very quickly than land because it is made up of the liquid now. So it takes times to warm up and also takes time to cool down. Right up to this point first. Now look at the point, next point. During the day, land gets heated by sun faster than the sea. The air over land also become hotter than the air become the sea. Okay. So we know that air also of land become hotter due to land is made up of solid particles. So hot air is light and hence it rises fast. So cold air from the sea who rushes into to take place the warm air place, right? So when liquid is heated, it rise up, and so here back end place is created. So from the sea, air comes down here, right? During the daytime. Next point is a conventional current is set up which causes breezes to blow from the sea to the land. In this way, during the daytime, air comes from sea to the land, right? Similarly, at the night time, during the night, land cools down faster than the sea, and the air over the land becomes cooler than the air over the sea. The air over the sea being warmer than the air over the land rises. So cold air flow from the land rushes into the sea, right? This is the point for the night time. So a conventional current is set up which causes breeze to blow from land to the sea. So write this point. Now look at the thermal expansion. Some common observations are listed below. So when a thermometer is placed in the mouth of a person with fever, you observe that thread of mercury rises along the bore. Okay? So when a body of any person having fever, that time its molecule is high now. So that time threads of the mercury rises. Next point is telephone wires sag more in summer than in winter. So that time it's expand now. That is called thermal expansion. And when water is boiled, it rises up in the vessel. That is also called thermal expansion. So these observations suggest that substance increases in size or volume when heated. So solid liquid gas when it is heated, it expands its size and volume also. The expansion of substance on heating is called thermal expansion. It is clear from the experiments alongside that gases expand more quickly, more than liquids, and liquid expand more than the solid for a given temperature changes. So, uh, in solid liquid gas, liquid expands more as compared to solid and gas. That is called thermal expansion for the liquid. So, right up to this point, then we will study one by one solid liquid. Now look at the next point, understanding the cause for thermal expansion. So when a solid is heated, its molecule execute larger oscillation about their mean position. So when a solid is heated, its molecule execute larger oscillation about their mean position. Right. This increase in the vibration of the molecules means that force during the collision are greater and molecules are driven farther apart. So next point is thermal expansion of solid. So solids have a definite shape and have a definite volume. Whenever solid is heated, it expands in all directions. Consequently, the surface area and volume of the body increases, right? When solid body is heated, it expands, right? So there are three types of expansion: linear expansion, superficial expansion, and cubical expansion. Linear expansion increase in the length, superficial expansion increase in the area, and cubical expansion is increase in the volume. So solid, so three types of expansion: solid, liquid, and gas. So write this point, then I will explain one by one. Next point. Now look at the first point, linear expansion, which is for solid. So the thermal expansion of body in a one dimension is called linear expansion. So coefficient of linear expansion is also called defined as increase in the length per unit original length or per degree rise in temperature. This is for coefficient of linear expansion, that is called alpha. So it is denoted by alpha. It depends on the material of the rod. So unit for alpha will be as seen from the formula, the ratio of the length has no units. So alpha is basically change in length upon original length. So both, so it is the ratio, so it doesn't having any units. So unit depends on the temperature scale only. So if the temperature is expressed in degree Celsius, then the unit per degree Celsius will be degree inverse. So it will be 1 upon degree Celsius. Our next unit is SI, unit of coefficient of linear expansion will be Kelvin per Kelvin. So write these 2 points, then I will explain one next one. So next point is solid expand on heating. So heated ball doesn't pass through the cold ring. If both ball and ring are heated, the ball will pass through it. It shows that ball and area of the hole in the ring both increase when heated. So suppose a ball is heated on this ring. So when both are heated now, that time the both expands. And next one is liquid expansion on heating. So liquid expand and rise up the tube when heated. So you can see that we are heating this tube. So liquid expand on heating. So liquid expand and rise up the tube when heated. So you can see that here there is liquid and we are heating it. So it is rising up. And in the gas expands on heating. So this one is rise for the liquid and this is for rise for the gas. So warmth of the hand is sufficient to cause the air to expand and bubbles up through the water. Okay. So you can see that there are bubbles here. So this is a gas particle in the air, in the water. Now look at the next point, brass alpha. Alpha is the coefficient of linear expansion. So it is given 1.10 10 raised to minus 5 degrees Celsius. It means that if a brass rod of length 1 centimeter is heated through 1 degree Celsius, the length will increase by this amount, 0.00018 centimeter. So alpha for the copper will be 1.7 10 raised to minus 5 degrees Celsius. Right. Now look at the next point. So if L1 and L2 are the lengths of the rod at the temperature T1 and T2, then the coefficient of linear expansion will be L2 minus L1 divided by L1 into T2 minus T1. So this will give the coefficient of linear expansion. So this is the formula for linear expansion.
So
Right?
what do they mean by coefficient?
Coefficient means it is the linear expansion coefficient. Means suppose I am writing an equation like ax plus by or equal to c. So here a is the coefficient of x and b is the coefficient of y, right?
Acha, that way. Okay, got it.
That way.
Got it, sir.
So in the formula form, you can write the linear expansion as LT equal to L naught into 1 plus alpha T. So alpha is the length at temperature T and L naught is the initial length of the rod and alpha is the coefficient of the temperature. So L naught is original length and LT is the length at temperature T. So initial temperature will be 0 degrees Celsius. So this is the formula for linear expansion. So solid show three types of expansion. First is linear. Now next one is superficial expansion. And superficial expansion is also called aerial expansion. So coefficient of superficial expansion of substance is defined as the rise in increase in area per unit original area per degree rise in temperature. So this will be the definition for superficial expansion. So its unit will be superficial expansion degree Celsius per degree Celsius or per Kelvin, because it is same. It is the ratio of change in area upon original area, right? So it is having no unit. It is having only temperature unit, degree Celsius. Look at the next point. It is denoted by beta. So aerial expansion is represented by beta. The value of beta depends on the material also. Okay. If A1 and A2 are the areas of the solid at temperature T1 and T2, so beta coefficient will be given by A2 minus A1 by A1 into T2 minus T1. So it will be per degree Celsius. So this unit will get cancelled, only remaining temperature, right? So its unit is per degree Celsius. Consider a square plate of 1 centimeter, this one. Okay. Let the original area is 1 centimeter square. When it is heated through 1 degree Celsius, each side increases by alpha. So it will show the linear expansion. Right. This is the formula for aerial expansion or superficial expansion. So right up to this point. So now look at the, suppose original area is 1 and we are increasing its area by a. So it will be 1 plus a square. So its expansion is 1 square plus 2a into 1 plus a square. So it will be 1 plus 2a plus a square. So this is the formula for increase in area, right? When we are hitting the square plate. So this is the super exponential expansion. So you can see this part is increasing now for this square plate. So write this for the superficial expansion.